this is going to be a pretty easy method to visualize. It's Quota Condorcet. I'm going to draw a few pictures that kind of describe how it works. So in a Condorcet election, you compare every two options and see which one has more support, and that guy wins. When you have a quota, you have somebody that you have multiple winners. So there's A, B, and C running, and say A already won, so A is selected. Now if A was more on B's side than C's side, and say B and C are pretty much, tied, then if A was more on C's side, then B should win, because the C voters already have a C type candidate. I mean, A is on their side. So the way you would draw that is you would say they prefer A to B and A to C. So these voters, their vote should not be counted more than once. And if A has already accepted their vote, A is giving these voters power because the voters voted for A. So you don't want to give voters more power than other voters. You want to be equal. Every voter should be equal. And it's kind of like you're counting the vote twice if these people that voted for A now get to vote again. So if A is more on C's side, then you take out more voters from C's side because they liked A better than C. And you take out some voters from B's side because they liked A better than B. In this case, C wins the second seat. That's the gist of it. It's a pretty simple method. I mean, there are some details, like say A is a really popular candidate, like A was right in the middle. So now you have B and C, A, and say there were like 10 seats in the legislature. Well, you can't take out all these people for just one of the 10 seats. I mean, it wouldn't really be counting their vote twice to give them a second seat because there's so many of them. So what you do in that case is you just take out a tenth. So 1/10 of the voters, you cross that out. Actually, that should be from both sides. Really, actually, you should just total up the number of voters here and just take a tenth out. 1/10 of the total voters. 1/10 of the total voters. So these are details, but are important, and it just ensures that if a candidate is really popular, then people aren't going to be afraid to vote for them because their vote's going to not count twice, and they won't be able to have an input on the next set of voters. And a really popular candidate, if they get a lot of people voting for them, they can't give power to all those people the same as a smaller candidate could. So that's why you have this quota of voters. For 1/10 of the total voters is the quota if you have 10 seats. And this is just a detail, but it's important. So the idea is that if you have A, B, and C on this side, and D on that side, and there's a lot more people on the A, B, and C side, then you should be able to have an A person win, a B person win, a C person win, and a D person win. And that kind of divides up the territory equally. I am going to make a few simulations of this, because I'm just kind of sketching this out. I mean, I need to do the math. There's some math behind this. And it's hard to draw accurately 1/10 of something or 1/5. But the general idea of quota Condorcet is that you want proportional representation. And to do that, you don't count votes twice for somebody that's already been chosen. So this is, I guess I should write sequential, because it's also sequential. This isn't the name of a method, this is just, two properties of the method, or 3 properties. The fact that it's using a quota, that it's a sequential process, you pick one candidate at a time, then the next, and that it's a Condorcet method. So I think I've explained this idea, that you have a combination of Condorcet, which chooses the people that go basically undefeated, if you're familiar with Condorcet, and I've explained how you take a quota of voters out of the Condorcet method. I guess I haven't said that this is just a mini election. There can be a lot of candidates, and each mini election is actually, like you look at each pairing and see between A and B. If you put A first, then A is counted in your vote, and between A and C, choose A, and so on. Between B and C, choose B, and so on. And between C and D, choose C. So each of these blocks is a mini election between 2 candidates, and that's what this represents. And if somebody has already been selected, say C was selected, then for those people that preferred C over one of the other candidates, those people are, well, their vote doesn't count twice. So say this person, they scratch out their preference for D, but if they preferred A and B, and the race is between A and B, then choosing C doesn't affect their result. That would be like this section here. So just to bring it into a broader context, it's only the people that preferred the winning candidate over the other candidates, only their vote is affected by that candidate winning. So this got into a little bit more detail, but I was wrapping up. This is a quota method, it's sequential, it's a Condorcet method. And the purpose is to decide, in a multi-seat legislature where you have 6 seats available, how do you fill those seats so that every voter feels represented equally?